Now let us look at the next question. These set of questions, they are based on a passage. An initially parallel cylindrical beam travels in a medium of refractive index mu, which is a function of intensity I, and it is given by mu naught plus mu 2 I, where mu naught and mu 2 are positive constants and I is the intensity of the light beam. The intensity of the beam is decreasing with increasing radius. Now let us comprehend the passage first. If you look at the beam from side, the beam is traveling in the form of a cylinder. That means the rays, they are traveling, they are parallel to each other, and they form, their cross section is parallel. Okay. Now if you look at the cross section of it, it is like this. Rays are coming, these points indicate the travel of the ray. Okay, that means they are into the plane of the circle. Okay, now this is the case. Now when it encounters a medium, okay, now you have a medium, and the medium has a refractive index which is a function of intensity. Okay, so mu is given by mu naught plus mu 2 I. Okay, now when the rays, this is a side view, when the rays, they reach this interface, they experience mediums, they travel through mediums having different refractive index. Okay, and the refractive index at the center will be maximum because the intensity at the center is maximum. As you move away from the center, more the radius, lesser will be the intensity. And since the intensity is lesser at higher radius or more radius, the refractive index, since I has come down, mu will also come down. So the refractive index at this point, let us say this is mu dash, and at this point it is mu, then mu is more than mu dash. Okay, now if this is the case, then as you move away from the axis by distance x, what will happen? The refractive index here will be lesser. Refractive index closer to the axis will be more. So the speed of light at this point is more. Okay, and at this point it is less. So the speed of light closer to the axis is lesser and away from the axis is more. Okay, that means, let us say this is the center or the axis. So the speed of light which is coming through this ray is is less, and speed of light at this point is very high, it's more. Okay, so if you see the wavefront, which was initially a plane wavefront, okay, because the rays were parallel, so the rays, they were parallel to each other. So the wavefront must have been parallel before it is incident onto the medium, and once it enters the medium, the wavefront changes to something of this sort. Okay, it will be kind of a, this will be the wavefront. This is the shape of the wavefront. Okay, it is a sort of cusp. Okay, now let us look at the questions. As the beam enters the medium, it will. Now the beam, when it enters the medium, it only experiences different refractive indexes at different points, but it will not change its direction of travel. Okay, so if the direction of travel is not going to change, only thing that is going to change is the speed of light, then it would travel again as a cylindrical beam. Okay, So option D is correct. Now if you look at second problem on this passage, the initial shape of the wavefront of the beam is planar only. Okay, this we have just discussed because all the rays were parallel initially. Okay, this is the part of the cylinder. Okay, the speed of light in the medium is minimum on the axis of the beam? No. Same everywhere? No. Is directly proportional to the intensity I? No. It is maximum on the axis of the beam that we have just discussed. Okay.